A very common way of doing research in psychology is to use something that's called the correlational technique. If you're doing a correlational study, you're just going out there in the world and you're measuring the relationship between a couple of variables, and you're not manipulating anything, you're not changing the world, you're just taking the world as it is and seeing if one variable and another variable have anything to do with each other at all. You can have a more complicated study where you're looking at the relationships among many different variables, but to keep it simple, I'm just going to use an example where we have two different variables and we want to see if they go together. All right, let's do an example. Let's suppose we're doing a study where we want to find out if there's a relationship between a college student's GPA and how much alcohol he or she consumes. So if we were to do a study like this, we would go out and get a nice sized sample of university students. And for each person in our study, we would get two measures. We would get a measure of the person's GPA. What is their GPA right now? And we would get a measure of their alcohol consumption. And you have to be very specific about how you assess that. There has to be some operationally defined measure that you use. So it could be number of ounces per day, number of drinks per week, but there would have to be some standard way of measuring alcohol consumption. We're not going to worry about that detail right now, but I did want to bring it to your attention as something you do need to worry about in a real study. All right, so we go out and get our first subject in the experiment, and it's represented by this blue dot that just popped up. Now notice this person doesn't drink very much. The blue dot is way down low near the word none on the x-axis, but the person's GPA is really good. It's really high. So this person doesn't drink much and has a good GPA. Our second subject, on the other hand, looks a lot different. This person scores really high on alcohol consumption, but their GPA is not very good. Subject number 3 is kind of a moderate drinker, has a really good GPA. Subject number 4 doesn't drink very much at all, but the GPA is very low. And so we continue to add new subjects. Each one is represented by a data point. And the graph that we end up with is called a scatter plot. Sometimes it's referred to as a scattergram. I'm going to use the term scatter plot because it's more commonly used. Now, if you look at this, it does show us that there appears to be a relationship of some sort. In general, people who drink a lot seem to have lower GPAs than people who don't drink as much. Now, it isn't perfect. There are some people, like the individual in the upper right-hand corner, that drink a lot and have a really good GPA. There are other individuals, such as the one in the lower left corner, who hardly drink at all, but their GPA isn't very good. But in general, there tends to be this relationship where high alcohol consumption seems to be related to low GPAs. So we would conclude, just by looking at this scatter plot, that we have what's called a negative correlation between these two variables. As one increases in value, the other one decreases. So as GPA goes up, alcohol consumption goes down. As alcohol consumption goes up, GPA goes down. Now, it's not enough to simply look at the scatter plot and conclude that you have a statistically significant relationship. It's not enough to just look at a scatter plot and just by eyeballing it, figure out whether the relationship you have between two variables is statistically significant or not. You have to compute something that's known as a correlation coefficient. You're not going to have to compute any correlation coefficients in this course, but it's important that you understand how they work because throughout the term you're going to be reading about a lot of studies that report correlation coefficients, and I want you to know what those mean. After you calculate a correlation coefficient, you should have a number that ranges somewhere between -1 and +1. If you come up with a number greater than 1 in either direction, you've made some kind of mistake because you can't possibly have a correlation coefficient higher than 1. The correlation coefficient tells you two different things. First of all, it tells you about the direction of the relationship between two variables. Is it a positive relationship or a negative relationship? If it's a positive correlation, the two variables go up together or go down together. So, for example, if GPA and alcohol consumption were positively correlated, as the amount you drink goes up, your GPA also goes up. As your drinking goes down, so does your GPA. In our example, though, we found a negative correlation, so that as one of them goes up, alcohol consumption goes up, GPA goes down. You can tell whether the correlation coefficient is telling you that you've got a positive or a negative relationship just by looking at the sign. You don't have to look at the number at all. Just see whether there's a plus or a minus there. Because the plus tells you you have a positive correlation, the minus tells you you have a negative correlation. However, the correlation coefficient also tells you something about the strength of a relationship. How closely are these two variables connected? How well can you predict one from the other? And the strength of the relationship is revealed by the size of the number. The closer it gets to 1 in either direction, the stronger the correlation is. And a strong correlation allows me to make good predictions, so that if I know your alcohol consumption, for example, I should be able to predict your GPA if there's a strong correlation between the two variables. So if I ask you about the strength of a relationship, look at the size of the number and ignore the plus or the minus. For example, a correlation coefficient of minus 0.75 is a stronger correlation than a correlation of plus 0.2 because the 0.75 is closer to 1 than the 0.2 is. The closer a correlation coefficient gets to 0, the weaker the relationship between the variables is. So if you have a correlation coefficient right around 0, you really can't predict one from the other, and they seem to not be related to each other at all. This slide shows you a number of different relationships and how they would look on a scatter plot. The two at the top of the slide indicate what a perfect positive relationship, the one in the upper left, and a perfect negative relationship, the one on the upper right, look like. Notice that the dots are all on a perfectly straight line. There are no exceptions. In every single case, the person who scores higher on one variable also scores higher on the other in the positive correlation, and in the negative correlation, without exception, the person who has the higher score on one has the lower score on the other. In real life, you never see perfect correlations like those. Those would be a +1 and a -1 correlation, and those tend not to exist. It's more common to find correlation scatter plots that look like the ones in the middle. The one on the left indicates a positive correlation. There's a trend for the two variables to go up together. The slope of the line goes up to the right. The other one in the middle shows a negative correlation where they tend to slope down to the right instead of up. So the direction of the correlation has to do with what direction the slope is going. The strength of the relationship is how close are the dots to being on a straight line. The scatter plot at the very bottom of the page would indicate something pretty close to a 0 correlation. There's no rhyme nor reason to where these dots are. One variable seems to have almost nothing to do with the other. If I know your score on one variable, it doesn't help me make any prediction at all about your score on the other variable. So that's what a very low correlation would tend to look like. Sometimes a student will ask me, well, why do we need to look at scatter plots? Can't we just look at the correlation coefficient and know what the relationship between the variables looks like? And while that's probably usually true, every once in a while you get a funny relationship between variables like the one you see in the graph here. This is called a curvilinear relationship. And if you're just doing a plain old correlation without looking at the scatter plot, you might miss something very important. For example, if your data looked like the data in this scatter plot, the correlation coefficient would probably come out to be pretty close to 0, because this is not even close to being a straight line. On the other hand, if you look at the scatter plot, you can see that clearly there's a relationship here. If this was depicting the relationship between the variables in our example, what this would tell us is that moderate drinkers have high GPAs. and people who drink a lot or people who drink very little tend to have lower GPAs. And if we hadn't looked at the scatter plot, we might have missed that. Now, there are correlation coefficients that can help you assess the strength of a curvilinear relationship, but that's kind of beyond an intro psych course. For now, we're going to talk about correlation as just this straightforward relationship between two variables to see if it has a linear relationship of some sort. All right, so to review some things, when you've got two or more variables and you just want to naturally see whether they go together or not without manipulating, you'll use a correlational study. You can picture the relationship with a scatter plot. You'll calculate a correlation coefficient to see if it reaches statistical significance, which is something I'll talk about in the next set of PowerPoint slides that you'll look at. There are some advantages to correlational studies. If you want to collect a lot of data really quickly, correlational studies are usually the way to go. And if you're trying to study something that you can't study experimentally, it's your only choice. So if I'm interested in how people react to a natural disaster like a tornado or something like that, I can't manipulate that and make it happen and randomly assign people to have their house destroyed by a tornado or not. And even if I could, ethically I should not. So for some kinds of research, the correlational study is all you've got. Now, the disadvantage of the correlational study, the big one, is no matter how strong your correlation coefficient is, you can never conclude that you have a cause-effect relationship between your variables. You can't know that. So in the example we used, it would be very tempting if we had a correlation like we described, a strong negative correlation between drinking and GPA. It would be very tempting to say, well, a lot of drinking causes a low GPA. And that might even be true, but we can't say that based just on the correlational study. It could be the opposite, right? The people with low GPAs are struggling in college and they drink to make themselves feel better and to relax. And it isn't the drinking that's causing the low GPA, it's the low GPA that's causing the drinking. Or it could be that there's some other third variable that you're not measuring. Maybe the person has some sort of motivational problem that makes it difficult for them to work, and this thing is the thing that's causing the low GPA, but then in some way or other it's also something that causes them to drink a lot. So you just can't tell. So there is that disadvantage, but correlational studies have many strengths. In the next set of slides, you're going to hear about experimental methods and how they're different from correlations.